Good afternoon, this is Kavi Priya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the topic reflection of uniform plane wave at plane conducting boundary. So let's going to start the discussion with the what is a perfect conductor and what is a normal incidence, incident and the reflected wave, reflection coefficient, boundary condition at the conducting boundary, standing wave, finally the applications. So first, what is a perfect conductor? So the perfect conductor has three properties. First thing is that it has an infinite conductivity. Sigma will be equal to 0 and electric field inside the conductor E is equal to 0. E is nothing but it is an electric field. So the electric field inside the perfect conductor is equal to 0. Third one, any incident wave is fully reflected. So incident is equal to reflection. So these three are the properties of a perfect conductor. And first thing is that what is a normal incidence? So the wave strikes a boundary at 0 degree angle, then we call it as a normal incidence. It is one which simplifies the analysis since no tangential component change will occur. And next one, incident and the reflected wave. Incident wave is represented as EI and reflected wave is represented as ER. EI equation is E naught into e power minus j beta z, which is same as a reflected wave. Here reflected wave is represented as ER, which is nothing but minus E naught e power j beta z. There will be a negative sign is indicated over here and the phase reversal of 180 degree will happens over here. That is the difference between the incident and the reflected wave. Incident wave is one which travels in the x direction, and in case of reflected wave there will be a 180 degree phase shift will be there, and the amplitude will be multiplied by the negative sign in case of negative sign, which is nothing but -1 in case of the reflected wave. Next one is a reflection coefficient, which is represented as tau is equal to EI by ER, ratio of magnitude of incident wave to the magnitude of the reflected wave, which is equal to -1. So here the total reflection will take place and the same time there will be a 180 degree phase reversal will be occurring. And next, what is a boundary condition happens at the perfect conductor. At conducting surface, E total is equal to EI plus ER, which is equal to 0. So the electric field must be equal to 0. Tangential electrical field will be equal to 0. And this condition satisfies the Maxwell boundary condition. And next one, what is a standing wave and what is a power consideration in case of the perfect conductor? So the standing wave is one which occurs in the medium 1 when there is an interference between the incident wave and the reflected wave. So electric field nodes will be created at the boundary, and in case of magnetic field, antinodes will be created. No power enters the conductor. So P transmitted will be equal to 0 and all the power will be reflected. So the incident is equal to reflection. So P transmission is 0, whereas P incident, power that is being get incident, which is equal to power being get reflected. So total reflection will be takes place in case of the perfect conductor. So inside the perfect conductor, the value of E, electric field E is equal to 0. And next one, what are the applications in consider over this boundary? First one is waveguide. Guided electromagnetic wave will be very much important for efficient signal transmission. And next one is a shielding. Shielding is one which protects the equipment from electromagnetic interferences. And next one, radar reflection. It is one which detects the range of the objects under radar techniques. And finally, transmission line. It is one which convey the electrical signals over a long distances more effectively. And this is a summary what we have discussed so far. We have discussed about what is a perfect conductor and what is the properties of a perfect conductor and what is this normal incidence. And we have discussed about what is an equation for incident wave and what is the equation for reflected wave. So in incident wave and the reflected wave, there will be a phase reversal and the amplitude will be multiplied by -1. And we have discussed about the reflection coefficient tau and what is the value of this tau and what is the boundary condition at the perfect conductor. What is the equation for E total? And we have discussed about the standing wave formation and what is a power consideration in case of this perfect conductor. Whatever power that is being at incident will be reflected. There won't be any transmission occurs over here. And finally the applications. These are all my references. Thank you.